We take the Earth for granted. In going to the moon, it turns out that you can't take anything for granted. The processes that are available here on our world, as it spins and spins and spins, are not found on many other worlds. In fact, from NASA's probing and photography and detailed investigations, the kinds of processes we see on Earth that we take for granted, clouds and wind, and the sculpturing of the erosive atmospheric processes that lay our deserts and sculpt terrain, these are pretty much unique to Earth, with one possible exception of the planet Mars. Photographed from space, the deserts look banal and featureless, revealing little from orbit of the majesty, of the wondrous activity that has gone into shaping these very tortured landscapes. Literally millions, if not billions of years of terrestrial planetary history laid bare by the successive erosive forces of wind and water and erosion, cutting away sediments, cutting away volcanic lava fields, cutting away the layerings of rock, while the planet rotates on and on and on. And on that planet, from time to time, as we've now pieced together, there appear brief blips, brief artifacts, such as these stone ruins nestled in Canyon de Chelly in Arizona. Cultures which have arisen, lived full lives, and then mysteriously vanished into the history and the processes of Earth itself. From Genesis to desolation on Earth is a brief twinkling of planetary time. The Anasazi were born and disappeared in 1,000 years, a brief blink against the time that we find on other worlds, a blink against the geology which is scored in these canyon walls, produced by this flowing commodity that is so freely abundant here on planet Earth, liquid flowing water. Without water, there is no life. Without water, there is no geological life, because it is the water itself in its hydrological cycle of evaporation and rainfall and erosion which creates these splendid, stunning landscapes which stand in stark contrast to man's first look at another landscape, airless, barren, cratered, silent, desolate, waiting for the first human footprints that would betoken that we finally had left our mother world and journeyed to the moon. So let's recapitulate. The Earth has what the moon does not. It has water, air, clouds, sedimentation, which is basically mountain building out of sediments, and it has active mountain building, volcanoes building up huge piles of lava, igneous rock, etc., etc. What the moon looks like, because it does not have these processes, is what you see here. This is a photograph montage taken by Apollo 10 looking over Sinus Medi. This is Okhurt up here, this is Trisnecker. These are two craters called Bruce and Blagg. This is the region of the Central Bay in here. Notice it's dark compared to the bright highland terrain over here. It has been sculpted by very different processes. For one thing, there's an awful lot of empty space on the moon. The moon is 15 million square miles. That's the equivalent of North and South America combined, or the entire continent of Africa. And we've been there 6 times with 12 human beings, and we range 3 or 4 miles from the lunar module. Can anyone with any reasonable perspective say that we have really explored the moon? An entire world of millions of square miles of real estate, of landscapes, of unfamiliar terrain? The other thing the moon has, which the Earth of course does not, is an incessant meteor bombardment. Look at these hills. These are the hills that frame the Taurus littoral valley where Apollo 17 in December of 1972 touched down. Notice their shape. They're rounded and sculptured. There was a John Wayne film many years ago called The Sculptured Hills. The film should have been shot on the moon, because the hills on the moon are sculptured and have been sculptured for literally billions of years by one irresistible force and process: the constant bombardment by a meteoric rain. And here you can see that there is another component that is unshielded radiation. What meteors do not destroy, radiation, hard particles, atomic particles zipping along at almost the speed of light, within tenths of a fraction of a percent of the speed of light, will destroy over time. If we need any examples, all we have to do is look at other bodies that NASA photography has now shown us in the solar system. This is the asteroid Ida, which was photographed by the Galileo spacecraft en route to Jupiter a few months ago. As we close in, you can see that Ida has been exposed to an incessant bombardment of meteoric rain. Crater upon crater upon crater upon crater upon crater. Every time a little object hits, be it something the size of a grain of sand, or something the size of this auditorium, or something the size of Columbus, it is called a hypervelocity impact. The energy transmitted in the impact is on the order of nuclear explosion potential. At some masses and velocities, of course we're all hearing now about comet Shoemaker-Levy 9, one little chunk 2.5 kilometers across, which is going to deliver into Jupiter something like 100 million megatons of collisional energy. Without an atmosphere, with no shielding, everything from little bits of sand all the way up to mountain-sized asteroids will collide and collide and have collided for unending time. One of the validations that the astronauts did in fact go to the moon, contrary to the weird stories that have been circulating for 25 years, and returned home with almost 1/2 ton of rocks, is to be found right here. This is a little glass bead measuring about 1/100 of an inch across. This little glass bead has on it a little glass bead crater, formed by a tiny particle, tinier than the pinpoint of a pencil, striking the surface of this little glass bead as it lay on the surface in the moon dust at a hypervelocity impact, 10, 20, 30 miles per second. At those speeds, something like 10 to 100 times the mass of the impacting particle is ejected in all directions, producing a bombardment which over time, as the astronauts attested from their landings and their comments and their orbital photography and their observations, the sculptured hills of the moon. Rounded, gentle surfaces beaten into submission by billions of years of unrelenting bombardment from cosmic space. It's very important. In fact, if there's one thing I want you to go away remembering, it is that process operating on the moon. Because under those conditions, which can be typified here in a diagram that we borrowed from a lunar science conference paper delivered several years ago, what you have is impact, debris transport, downhill, talus slopes, level plains. There is one-way entropic degradation going on the moon. There are no volcanoes, there are no active mountain building orogenic uplifts, there is no erosive rain, there's no hydrological cycle. There is one process, and one process now, today, this moment, tonight, going on the moon, and it is an incessant cosmic meteoric rain. Now, if I seem to be belaboring the point, I'm about to show you why what we have now found is so in violation of that fact, of that model, that it begs for an explanation. A real one, not a fake one. A real answer and an explanation. Because standing on the lunar surface, photographed by Lunar Orbiter 3 in February of 1967, extending 1.5 miles above the moon, there is a shard of something, casting a